Monitoring Air Quality, presented by Science at NASA. Air quality is a global issue. Currents of air waft gaseous and particulate pollutants from region to region, country to country, and even continent to continent. Emissions from human activities, sunlight, weather, pollution from far away, wildfires, and wind-blown dust can all affect air quality, and it can change from day to day or even hour to hour. Addressing this global issue requires a global effort, and that effort is in the works. The United States, South Korea, and the European Union will each launch geostationary satellite missions from 2018 to 2022 that will become part of a global air quality monitoring system, including other satellites, ground networks, air quality models, and airborne sampling. Geostationary satellites stay in place over a single location on the Earth, allowing instruments on board to collect data continuously throughout the day to monitor the ever-changing state of the air over that part of the globe. In May 2016, NASA and the Korean National Institute for Environmental Research began a precursor mission to prepare for this unprecedented global air quality monitoring system. The Korea-United States Air Quality Study, or CHORUS-AQ, is assessing air quality across South Korea using observations from aircraft, ground sites, ships, and satellites. CHORUS-AQ is one of several field experiments going on this year that will be monitoring the health of our planet. James Crawford of NASA's Langley Research Center says CHORUS-AQ is helping scientists understand the factors that affect air quality, how surface emissions, atmospheric transport, and chemical transformations interact, and how they're changing over time. CHORUS-AQ prepares us to take advantage of the upcoming global system by exercising all of the observational perspectives, integrating the data, and using them to test our models of air quality. The Korean Peninsula is an excellent locale for studying air quality. The city of Seoul is one of the globe's 5 most populated metropolitan areas, and local emissions from its vibrant transportation and industry present challenges to air quality similar to those faced by megacities worldwide. Korea's position, downwind of China, also highlights the issue of transported versus local pollution. In addition to pollution from Chinese megacities, plumes of dust from the Gobi Desert can make their way to the Korean Peninsula. This complexity of accounting for local pollution and pollution imported from elsewhere demonstrates the difficulty in devising strategies to improve air quality. 3 aircraft are involved in these studies. NASA's DC-8 flying laboratory, carrying NASA and South Korean instruments, is directly measuring the composition of the atmosphere over the Korean Peninsula at altitudes between approximately 1,000 and 25,000 feet above the ground. A NASA King Air is flying higher with remote sensing instruments that simulate satellite observations. South Korea is flying its own King Air, which carries South Korean and NASA sensors to directly measure the atmosphere in areas the larger, less nimble DC-8 can't access. In addition, Korean scientists are collecting data from their ground-based air quality monitoring network consisting of more than 300 stations. They are also hosting NASA instruments at some of the ground sites. Together, the South Korean and U.S. researchers are planning and coordinating the flights. They are jointly providing air quality forecasting from an array of model simulations. The CHORUS-AQ data will provide an important test of these models and their ability to accurately forecast air quality conditions. Improving the models is extremely important, explains Crawford. Confidence in our ability to simulate current air quality allows us to take the next step and predict how air quality would respond to future emission scenarios. Testing how various policies to regulate polluting emissions would improve air quality enables responsible decision-making. People around the world will benefit from this team effort. Atmospheric scientists, using data from CHORUS-AQ and the future constellations of geostationary air quality satellites, will work together to help make those benefits a reality. For everyone who breathes the air, more fresh science news may be found at science.nasa.gov.